So today, I will discuss to you one of the topics for lesson 2 still in module 1. So this is dynamics, and we're going to talk about the mass moment of inertia. So let's start with the elementary definition of mass moment of inertia. So when we say mass moment of inertia, this is the ability of a material to resist angular rotation. Okay, ang mass moment of inertia, let's say we have axis here. Let's say muna siya to axis, and then you have a certain mass here. Muna siya to axis, ha. Then you have a certain mass here, or you have a certain block with mass M1. Then of course, M1 is measured a distance D1 sa ato axis. So monitor axis din natin M1. Now, if it has a greater mass, and then it would be very difficult for us to rotate this mass with respect to this axis tungod kay bugat siya, and then tungod pud sa kalayo niya with respect to our fixed axis. However, if we have another mass here, let's say this one is M2, so M2 mass 2, and then mass 2 is closer siya sa axis compared with mass 1. So therefore, si mass 2 mas dali ra siya tuyukon kaysa ni mass 1. Let's say both masses have the same have the same value of mass. Let's say 5 kilogram. So the farther you are, the greater ang imong mass moment of inertia. Layo naman kay ka, it's very hard to rotate mass 1 with respect to this axis. Kaya layo man kay siya. So it possesses a greater value of its mass moment of inertia. Therefore, if nagtuyok pud ni siya, if it is in a state of motion, so nagrotate ni siya, ha. Siya may nagrotate ni siya. So tungod kay may possess siya of greater mass moment of inertia, therefore lisod po kayo nimo siya pahunungon. Okay, lisod kayo siya pahunungon. And then for mass 2, kung nagtuyok pod ni siya, since dali ra pod siya patuyokon, as what I have said, this is very easier to be rotated since it is more closer to the axis. So therefore, dali ra pod siya pahunungon because gamay iha mass moment of inertia. So by that, we can formulate the formula for our mass moment of inertia. Formula. So, mathematically speaking, the mass moment of inertia is abbreviated by this capital letter I. So, mass moment of inertia is equal to, let's say if we have a system, a mass system, so that is just the summation of the product of the mass of an object times the distance. Let's say that is r na lang squared, the distance of the mass with respect to our axis, the fixed axis where it is about to rotate. Okay, summation na siya. Let's say if we have assuming we have 5 masses on our system, 5 masses, so that is I is equals to the first mass, then the first distance squared plus the second mass and its corresponding distance from the fixed axis squared plus mass 3 r3 squared until mass 5 r5 squared. Now, the mass if you are class, bugad ka, dako kag moment of inertia because by looking at the basic formula mr squared here, diba? If our mass is higher, therefore we have higher value of our moment of inertia. The same thing with our distance from the fixed axis. If this one is higher, meaning dako pag kay kaog mass moment of kanang inertia. So inertia is the ability to resist angular rotation, and we can apply this mass moment of inertia on several things that we can see in our working area or even in our environment. Now, in mechanical engineering, we can use this principle in analyzing the motion of our flywheel. Motion of our flywheel. Okay, Mr. Pagas, are you familiar with kanang flywheel? Familiar ka ani? Wala. Actually, flywheel part ni siya sa kuan. Part ni siya sa ato ang automotive engine. So, I think nakaibaw na siguro ka ka familiar siguro ka og kuan makina sa sakyanan. Naka-familiar ka og kuan makina sa sakyanan? Di tanan. Pero kaibaw ka nga nadyo makina ang sakyanan. Okay, okay. So, ang atong sakyanan, of course, na siya kuan. Our car has an engine. So, mao man ay nag-power up sa sakyanan. Inside the engine, naata ni. So, inside the engine, we have flywheel. And flywheel, so, naas tayo root word nga wheel. So, dako kay na siya nga disc. Circular disc. Connected na siya sa atong piston. So, dako siya circular disc. And then, kana siya bugat kay ni. So, meaning it has mass which is very, very large. Very, very large. Dako kay value sa iyahang mass. Connected na siya sa piston. So, if we have a huge mass and then dako pa gani siya. So, therefore, it possess greater radius. So, dako iya R. So, therefore, ang iyahang corresponding I is equals to mr squared. So, mass sa flywheel then the radius po sa flywheel. So, see, if dako gali siya og mass, bugat siya, dako pagid kay siya radius, kay this is a circular disc. Kaning flywheel mo siya disc. Now, dako iya moment of inertia. So, sir, unsa may purpose nganong, what is the use if it has kanang greater mass moment of inertia? So, kung dako na siya mass moment of inertia, then, kung connected ni siya sa flywheel, connected ni siya sa piston, sa atong engine. So, ano na siya? Piston, kay kuan siya, series na siya. So, mo ni ang shaft. Gatuyok ni. Then, ang piston na dahil na-combustion nga mo-occur dira. So, pag-tuyok niya, of course, ang flywheel pud kay mo-rotate. Now, ngano ang reason, unsa may hinungdan nganong ang piston kay mubalik siya og kanang kuan pataas, since ang action sa piston kay moubos then mobabaw na pod, then moubos mobabaw na pod. I hope ma-familiarize ninyo sooner, especially sa inyong higher subjects na. So, kani pag ubos niya, of course, ang nagpaubos niya is ang combustion. So, inside our engine, mubutom na siya. So, na combustion nga mahitabo, then maubos siya. And now, unsa na po force nga mo drive niya pabalik. So, ang mo force nga mo drive niya pabalik is kani siyang flywheel. Tungod kay si flywheel class, di man mo siya mapugnan. Kung once ang flywheel magtuyok na, wa na. Lisod na kay na apugnan. Tungod sa ato ang principle nga gi-apply, the moment of inertia. So, mo nang good kaayo ni siya nga kanang ang flywheel as energy storage para ma-balance niya or ma-keep niya ang piston, ang movement sa piston in harmony. So, siya usa ka application sa mass moment of inertia, and then we can also apply this in our satellites. So, satellites. Now, I think I already discussed this principle during our discussion on escape and orbital velocities. Ang satellite pod in order to decrease their velocity as soon as they reach a certain altitude at the sa ato ang kanang in the space. So, kung maka-reach na siya at a certain altitude from the Earth's surface, let's say this is our Earth, and then atong satellite kay located na diri, so outer space na ni siya. So nana atong satellite ari, and then of course, di ba kay, or rocket, di ba kay may escape man na siya sa Earth's gravity. Pag abot niya dito, syempre in this region kay kani akong gikuanan gibutang hidden line, below niini is atmospheric region, meaning we have air or atmosphere here, so we have drag or resistance. However, outside this region kana ato is space. We're in unsa may condition sa space. Mr. Pagas, ikaw, what do you think? Sa outer space ba, napabagi hapoy atmosphere or air, or wala na? Kaya wala na gravity, so we don't have air, di ba? Wala tayong matter nga to, so therefore, yung space is a vacuum. Now, if vacuum atong space, so therefore, lisod kaya na siya i-break. Diba? Lisod kayo pahunungon ng ato ang satellite nga nagtuyok. So what they did is nasa lagi device nga kanang kuan, nga kanang equipment nga mopahunoan nga satellite. Let's say our satellite is in this shape. So kana siya. Of course, nag-rotate ni siya. Rotate ni siya ginsakto. So para mohunong ni siya, actually magamit pud ang momentum nga principle ani, since we already discussed the principle of impulse and momentum, and also the angular momentum. So kani siya, of course naa siya mass, kaning satellite nato we have mass and also the radius, right? Kay sa cylindrical man so mo na ang r niya, so mo na ang value sa moment of inertia. So gatuyok ni siya, massive pa gyud kung saan paghunong ani para di na siya motuyok, kay syempre lain kay mo sila nagtuyok. So what they did para mo hinay siya o mo came to stop, ilang gibuhat kay saman dapat ilan ning pagamyan, di ba? Kani siya kay na naman sila yung moment of inertia silang pagtuyok, ang goal nila is to reduce. So goal nila is to reduce the value of our moment of inertia. Kung saan pag-achieve, di ba? Si moment of inertia is directly proportional to the mass and the radius. So, can we reduce the mass, Mr. Pagas? Diri sa ato ang kuan, diri sa atong spaceship. Ato ba siya modify or ang radius lang ang pwede ma-modify? In your own kuan, in your own opinion, sa mga di ba? Mao man ang relationship, I is equals to mass times the square of the distance from this axis. Let's say momni ang axis. What do you think? Can we alter the value of mass or ang radius ra? Pwede. Okay, sa imo lang. Actually, pwede siya. Okay, pwede siya. Pero unsa man, ato bahaton sa mass, di ba? Kaya atong goal is ato ikuan, ato ni sana. Ang goal nato ani is ato pagamyan iyahang kuan. I mean, dili siya pagamyan, padak-an day nato. Mr. Pagas, ato padak-an ang moment of inertia. Why? Kay kung dako na siya moment of inertia, since by the principle of kanang kuan momentum, kung imo increasean ang moment of inertia, kay mo gamay ang rotation, tungod kay kung dako na kag moment of inertia, di ba? Lisod na kay tuyokon. So ang atong goal ani da is not to reduce. So ato da ikuan, ato i-increase. Balik ta again by the principle of angular momentum. So by angular momentum, we are going to increase our moment of inertia, because angular momentum is ito sa ni erase na to kadali. Angular momentum is defined as h equals iw squared. So I hope naka-remember pa mo ni iw squared. So therefore, if I is greater than si w ani, which is the angular rotation, mo decrease siya. So that's why ang atong goal is ato ipa-increase ng I para mo hinay ang iya tuyok. Kay mo man atong goal, mo hinay ang tuyok sa satellite para mo stabilize siya. So therefore, from our formula for moment of inertia, mass moment of inertia, that is mr squared. So mo ta mag-ingon, yes, we can do both. We can modify mass and also the radius. So mag-una ta sa mass. So siguro magdagdag ta og mass, but how? And then magdagdag ta og radius para mohunong gid para maka-achieve bitaw dako nga value sa atong moment of inertia para mo gamay ihang rotation para mohunong siya. So what they did sa atong scientists is na sila ikuan. Okay, sorry. Ito sa ni-erase. What they did is they add some mass or nagpakuan sila, marabag sa tawagan ni nagpa-spin sila og mass. Let's say mo na ang string, nagpa-release sila og string wherein na nakakabit dira nga object with mass m1 pod. Did the same thing on the other side para mo counteract lisod man kay dili i-balance pod ang system kay basig daot pod ang ato ang space, a rocket. Then another mass m1 gyapon sila because they have the same mass, and then of course they have the same distance r1. So in this case kani pong duha, di ba, kung ang kanay siya kay nag-rotate ngadto, pwede pod isabay ni siya rotate, but mahinay ni tungod kay what happens to our I now? I is equal to the mass of the rocket then the radius of the rocket squared. Nanay additional nga mass 1, duham ni sila. So therefore we can have two values here. So we're going to multiply it by 2. So that is twice mass 1 then r1 squared. So see, nadagdagan ta ani nga values ato ang moment of inertia. Now, ang atong moment of inertia is may increase na. So therefore, by the angular momentum nga principle, kung mag-increase ang atong moment of inertia, mugama iya rotation mo nang muhunong na ni. So mo stop na ang ato ang rocket sa pag-rotate with along its axis. So nakuha ra Mr. Pagas. Okay. So mo na siya ang application sa ato ang moment of inertia. Now let's derive some basic geometries sa basic geometries and its corresponding formula for its mass moment of inertia. So mo na yung pinaka basic kaning thin disk. So the shape of our thin disk is this one. So circular ni siya, and then it has a corresponding thickness. So ato lang ikaw na i-drawing ani. So di kan siya perfect. Then natay axis of rotation. So kanang drawing. So axis of rotation na siya. Assuming nga siya rotation. Okay. And then ang disk, of course, di ba? It has radius. So we put here radius r. And then of course nasa thickness. So ang thickness niya is t. Okay. Let's derive. So we all know that mass moment of inertia by elementary definition is just the product of mass times the square of r. But in this case, class, this is only applied if our mass is kanang class. Atong mass kay kanang concentrated on a particular point. So this can only be applied if we have this kind of setup. Let's say this is our axis, and then the distance to a certain mass, that is r. Ang mass kay located ani, meaning the entire mass is concentrated on that distance. Kana maka-define ta that is mr squared. However, for a thin disk, lahi man siya since naka full geometry, and then wa man ni naka-isolate ning entire thin disk on a certain distance, and then ato man i-considered nga with respect to this axis. Let's say this is y-axis. So therefore, di na ito magamit ng elementary definition or formula. We cannot say directly that the moment of inertia for thin disk is just its mass multiplied by its own radius. It's not like that, since maayo og kuan, maayo og kaning si tin disk naka-rotate siya on another axis. Let's say this one, this M nga axis, then na siya distance ana nga D1. So kana siya pwede din ta makagamit aning elementary definition because in this case naka-concentrate na si tin disk at a certain distance from another axis, which is the M axis. However, tungod kay makuha ra ta og moment inertia sa tin disk with respect to its own axis of rotation, kani akong indicate diri kanang y axis. So therefore, we cannot use directly the elementary formula for its mass moment of inertia. So ang atong buhaton is we are going to use the general formula for the moment of inertia, and we are going to employ integration. So Mr. Pagas, kuha na mo, naabot na mo sa integral. Okay, naabot na. Okay, so I think na mo yung knowledge ni ini. So let's apply integration because the general formula for the mass moment of inertia is I equals the integral of your mass times the square, r square, then from r1 to r2. Actually that is mrdr din siya. This one is, so I mean mr squared lang sa ta, but since ang integration kay mag-require siya og kanang variable ni ini, so it will now make to this mr dr, so derivative of the radius, so mr dr. Kay kung ato ni ikuan unit analysis, mass then radius multiplied by the change in radius, so mo result ra gyapon siya into mr squared. Okay, so let's apply this. Ato ni siya kanang apply sa ato ang object nga given kaning disk. Okay, so let's find first the mass of this disk, di ba? As you remember, we have density equals mass over volume. Okay, natay formula nga density equals mass over the volume. So ang atong mass day, mass is therefore density times volume. Okay, density of the mass equals density times volume, and then for a kanang kuan disk, the volume is equals to, so may volume ni ini Mr. Pagas, volume sa tin disk, di ba? Ang tin disk kay mo siya og kanang cylinder pero gamay lang kaayo og length, right? Mo agree ka Mr. Pagas? Okay, so the volume for the formula for the volume of cylinder is pi r squared, right? So pi, then our r here is capital letter R squared multiplied by the height, which is the thickness, so pi r squared t. So therefore we can say that our mass is just equal to density times the volume, which is pi r squared t. Okay, let's assume nga variable sa ang ato nga radius. Okay, kay let's say kung mag-base ta sa kuan good elementary definition, I is equals to m r squared, we assume that r here is a variable, and then sa atong mass pod, if dili ta gusto nga mag-fix atong value sa mass, let's say the mass also varies with r, so we can say that from this previous value of our mass, we can say that mass is a function of the radius of the disk, which equals to pi rho density pi r squared. So kani si r ato na i-place og small letter given that variable na siya. Okay, now if we're going to take the derivative of our mass here, so that is derivative of mass is equal to, taking the derivative of this, we have 2 rho pi r t. Okay, and then we have here dr. Okay, now from the elementary definition, we now have I is equal to, actually, ato na siya ma-derive, that is r squared dm. Since nag-derivative na to sa PCAS, of course, we also need to take the derivative of the left side para ma-equal ang equation. So here, since si r squared kay variable man siya, so remain as it is. However, we already get the value of our derivative of mass, which is equal to this. So plug in, that is 2 rho pi r t dr. Okay, then simplifying further, so derivative of its moment of inertia, that is 2 rho pi r cube. So ato ibutang diri si t di ay, sorry, ato ibutang diri kay ang thickness pod sa kuan disk kay constant pod na siya, 2 rho pi t r cube dr. Okay, then we apply integration. So integral, and then dapat sa atong integration, di ba, namatay limits of integration. So asa nag-start for our example, for our thin disk, of course ang radius mag-start sa center, di ba, mao na siya start sa center, so that is 0, wa matay radius ara, that is 0, until asa nag-end, until the outer radius of the kuan of the disk, that is capital letter R. So padong R, so 0 to capital R. Okay, so the integral of di is just I, so I is equals to this one. So pwede na nimo ma-factor out ang mga constant, that is 2 rho pi t, then integral of 0 to r, then r cube dr. Okay, Mr. Pagas, unsay integral sa r cube? Naka idea? What is the integral of r cube? Okay, good. That is r4 all over 4. Since for power rule, we add the exponent, and then whatever you have done in the exponent will be copied on the denominator. Okay, and then don't forget to put the limits of integration. Yan na siya. So here, simplifying further, that is 2 pi t, then we have big radius 4 over 4 minus 0 over 4. So ma-0 na gina siya. So unsay nahabilin kay ato ni continue, that is equal to I equal to 2 rho pi t, then we have r4 over 4, then ma-cancel na siya, 2 na yung mabilin, so that is 1/2 rho pi t r to the 4th. So remember from our initial nga nakuha for mass, di ba? Here we have mass value of rho pi r squared t. Now if we're going to split this, so pwede buta makaingon nga kani siya is equal to 1/2 rho pi, makuha tag 2 ka r, then t, then ma-remain ang 2 pod ka r. So kani siya, kani siyang nasa middle ng expression is just equal to the mass of the disk. So therefore we can say that I is equal to 1/2 mass times the square of the radius of the circular disk. So therefore that is the formula for solving the moment of inertia of our circular disk with respect to this y-axis given here, as you can see in the figure. Okay, so ang thin disk pod, I mean the mass moment of inertia of the object again is always dependent on the axis. Now kung mag-change na po tag axis niini, let's say we're going to put another axis, let's say this one, we call this the x-axis. So ang formula for the moment of inertia with respect to the y-axis and with respect to the x-axis are both different. Okay? So, again, maglahi-lahi gyud ang ato ang kanang value sa atong moment of inertia kung maglahi-lahi po ang ato ang axis of reference. So, take note with this one. So, again, the moment of inertia of a tin disk with respect to this axis, which is perpendicular to the surface of the tin disk, passing through its center, is equal to 1/2 mass times the square of its radius. So, naay question? Naay question, Mr. Pagas? Okay ra, nasabtan ra? Okay, so let's proceed to the derivation of the mass moment of inertia of our sphere. Let's say we have a sphere with an axis of rotation here. Actually, ang sphere gyud at any orientation, equal ra gyud gihapon ang sphere. At any orientation, ang mass moment of inertia is still the same. Kay, di ba, ang sphere kay symmetric gini siya nga po ang geometry. Let's say, rotate siya aning axis. We just call this one as the x-axis. Of course, ang sphere, let's say, this sphere is solid. So, solid sphere. Of course, nagin na siya radius nga r. Ang r nga ato ibutang diri mo na siya ang fixed nga value. But during our derivation, let's just assume a small letter r, which is a variable. Okay, so for sphere, ang base sa book, so para natay basis sa derivation from the book, the moment of inertia for sphere is 2/5, that is 2/5, then mr squared, mr squared. So kita ang r, the radius of the sphere. So mo na siya atong kuhaon sa ato derivation. So let's derive na. Now before deriving, of course, ato sa kuhaon ang mass sa sphere. So by the principle, density is equals to mass over volume. So we can derive that mass is equals to density times the volume. So, Mr. Pagas, what is the volume of, the formula for the volume of sphere? That is, ang sama na siya. Okay, 4/3 pi, then r cube, right? Okay, okay, 4/3 pi r cube. Okay, so, ako gibutan diri og small letter r, because let's assume that the mass is a function of our radius. So, wala na ko na siya gi-capital letter kaya wala ta nagbase sa ato object because nag-derive pa man ta ni. Assuming that r here is a variable for the radius. So, for the radius of sphere. Okay? Because kung mudako ang radius, syempre mudako po ang mass sa ato sphere. Okay. So here, kainin po nga by or from the elementary day. So from the elementary formula, we can say that the mass moment of inertia is just equal to the mass times the, kaya ito ni small letter, kaya di mo ni siya constant, nag-vary man, the square of r, or in a function form that is I of r din siya, I of r. Kaya ang mass moment of inertia is a function of our radius. I of r is equals to mr squared. And then if we're going to take the derivative of both sides, that is the derivative of ir. So the derivative of ir is just equal to r squared, the derivative of mass. Because ang mass may mag-vary nato since mass is also a function of our radius. So from our previous year, diba? Kani siya function po na siya sa ato radius. So therefore, from this formula, ato sa isolve ang derivative sa ato ang kuan, sa ato ang kanang mass nga function. So taking the derivative of this, that is mr is equals to density 4/3 pi r cubed. Taking the derivative, so the derivative of our mass is equal to 4/3 multiplied by ang exponent niya ni mahimong 3, then density pi r squared, then derivative po sa r dr. Okay, then since nakakuha naman tani, substitute na po dito sa dm. So to continue, so therefore we have the derivative of kuan, so sorry, ito erase. So therefore makaingon ta nga the derivative of our inertia is equal to r squared multiplied by the derivative of mass, which is kanin siya makancel din eh, so that is 4 rho pi r squared dr. Okay, then combine like variable, so that is 4 rho pi r to the 4th dr. Okay, the next is we're going to take the integral on both sides para matangtang natin derivative. So integral dr, so since this is a function of r, so ang initial nga radius sa sphere, since this is a solid sphere, so mag-start sa center point, that is 0. So 0 ang radius ara, so that is from 0 to the radius of the sphere, which is capital letter R. So the same thing with here, 0 to R. Then again, that is equal to I equal to, in this case mag-apply na po ito gani ang power rule. So just factor out the constant 4 pi r or 4 rho r. Then ang integral sa r to the 4th is r to the 5th over 5. Sakto ba, Mr. Pagas? R to the 5th over 5. Okay, so r to the 5th over 5, then from 0 to r. Then we're going to substitute the going to substitute r here, so that is 4 rho pi, then that is r capital letter R is to 5 all over 5 minus 0 all over 5. So kanin siya may mong 0, so therefore ang habilin kay si 4 rho pi r to the 5th all over 5. So this is the moment of inertia for our solid nga sphere. But in terms of mass, so ato isuwat area balik, that is I is equals to 4/5. So 4/5 pi 4/5 rho pi r to the 5th. So pi r to the 5th. And then we all know that the mass or the density is equal to the mass over volume. That is, density is equals to mass over volume, or in our volume, so that is mass all over the volume is 4/3 pi r cubed, right? Pi r cubed. Siya ang density. Ang formula sa ato ang density for sphere. So pwede na to pwede na to i-plug in dira. So that is 4/5. Density is mass divided by 4/3 pi r cubed, and then this is r to the 5th. Then kaning 4 makancel, then napalit pi ari. So si pi makancel pod, r cube ang r 5th makuha na lang ang r squared, then ang 3 butang sa taas, so that is 3/5 m then r squared. So mas siya ang moment of inertia. Okay, masave din ni kanin siya, this is 3/5 day. sorry, kani siya is 3/5. So therefore, mo na siya ang mass moment of inertia for our kanang solid nga sphere. Okay, my question. My question, Mr. Pagas. Okay ra? Okay, so basically mara gani ay mo follow, especially kung mag-derive ta. So gamit log integration, then solve for m, then take the derivative. So mara gani buhaton, take the derivative, and then after taking the derivative, so plug in na lang ang mga values. So may plug in ang mga values, then after that kanang ato na makuha ang iyahang moment of inertia. So again, for the volume of the sphere, muna siya 4/3 pi r cube. Then ito i-substitute, so I think okay naman. So 3/5 gid siya, that is 3/5 m r squared. Kaya I think okay man ito ang pag-solve, okay man. Okay, so let's proceed to the next nga geometry, which is the thin ring. Okay, so for thin ring, man siya illustration. So natay mara siya donut, then of course nagyapon na siya thickness. So assuming that this is our axis, pass siya sa center sa ring. So we label this one as the x-axis. Then of course tendency ni ang thin ring nga rotate anang axis. So ang iyang inner radius kay label na to nga r1, iyang outer radius kay ato na siya i-label nga r2. Okay, then by using the integration, so we know that density is equals to mass over volume. Okay, mass over volume, and then we know that mass is equal to density times the volume. Then assume nga kani siya natay thickness sa ato ang ring t. Okay, so here unsa man ang formula sa volume sa kanisiyang ring. But the volume for the ring is equal to the outer cylinder minus the inner cylinder. So that is 2 pi, then that is r2, 2 pi r2 squared times the thickness minus 2 pi r1 squared times the thickness, diba? Then pwede po nato ma-factor out ang 2 pi t, so that is rho 2 pi t, then r2 squared minus r1 squared. So wala siya. Or rearranging, we have 2 pi rho t, then r2 squared minus r1 squared. Muna siya ang mass. That is the mass of our that is the mass of our ring. Now in order to solve for its moment of inertia, so the moment of inertia by using the integration, so we're going to integrate. So here ato makuan diri is naatay radius. So we say that m as a function of r is equals to the density, that is 2 pi rho t, then function po siya sa r since difference man siya, so we can just say that that is 2 pi rho t, then r 2 pi rho t r squared. So kanang kuan mo na siya, and then we have I mass moment of inertia is just equal to m r squared, diba? And then in terms of function form, this IR is equals to the mass, then function r squared, and we know that mass is equals to 2 pi rho t r squared, so plug in that one, so that is 2 pi rho t r squared times r pa gyud, so that is r to the fourth. Okay, dili pa ito mo dira mo take sa tawag og kanang kuanday derivative sa ato ang mass moment of inertia, that is the derivative of the mass moment of inertia is equal to r squared derivative of its mass. Okay, and then integrating, that is the moment of inertia is equals to, here dili na zero atong initial radius since atong initial radius is r1, then until r2, so that is r1 to r2, and then r squared, then we're going to take the derivative of this. The derivative of this is 4 na ni, 4 pi rho t, then r dr. Okay, 4 pi rho t r dr ang derivative ani. So that is the derivative of mass r is equals to 4 pi rho t r dr. Then isubstitute na diri, so that would be r squared 4 pi rho t r dr. Then ato i-extract ang constant, so that is 4 pi rho t integral r1 to r2. So we have here r cube na ni dr, and then pwede na nato ikuan, proceed na ta sa integration, that is 4 pi rho t, that is r to the fourth over 4 from r1 to r2. So here common na siya, so ato na siya i-cancel out, so therefore we have here pi rho t, then ato integrate sila, that is from r to the fourth, r2 to the fourth minus r1 to the fourth. Okay, and then unsa ra gyud kuan mass, unsay mass ato ang kuan, take note our mass is here, kani siya, is naman tay mass which is a function of our density pod, so therefore from here we can derive our density, that is the density is equals to mass all over 2 pi t, then that is r2 squared minus r1 squared. So ato na siya i-substitute nito para makakuha tag moment of inertia in terms of mass, that is pi multiplied by m all over 2 pi t, then kani siya kay r2 squared minus r1 squared, then multiplied by the thickness, then kani siyang r2 squared r2 to the fourth minus r1 to the fourth, equal ni siya sa r2 squared minus r1 squared multiplied by r2 squared plus r1 squared. Diba sakto ba, Mr. Pagas? Kani siya, kaning r2 to the fourth minus r1 to the fourth, diba mura siya og difference of difference of two squares. So na okay. So ato na i-plug in. Plug in na nato diri So we now have r2 squared minus r1 squared multiplied by r2 squared plus r1 squared. So cancel na siya kay pareha man. Then pi makancel, thickness makancel. So therefore our mass moment of inertia for a ring is we have mass over 2. May 2 sa ubos. Then multiplied by the sum of the radius, the square of the radius. So mass siya ang mass moment of inertia for the circular ring. Any question? No question, Mr. Pagas? Okay, so let's have an example problem for mass moment of inertia. So here, this sample problem is using the elementary definition of the mass moment of inertia. So let's say we are going to calculate the mass moment of inertia of the following system of masses with respect to the z-axis. So we have here figure and illustration. Figure and data. So we have here figure and data. And then with respect to the z-axis, let's say this one is the z-axis. So this one is the z-axis. And then we have mass 1, which is equal to 10 kilogram at 1 meter distance from z-axis. So let's say, can you see natay mass 1, then ang distance with the axis is 1 meter. Then next, nabuday mass 2 nga 5 kg. So let's say naday dapit ang mass 2. Mass 2, then 5 kg at 0.25 meter distance. So kana siya 0.25 meter. Then mas closer siya sa mass 1. Mass 3 is 1 kg still from the z-axis. So mass 3 nata diri. Mass 3, then 1 kg siya. Ang iyang distance from the fixed axis or from the z-axis is 0.1 meter. Distansya. And then mass 4, 6 kg, distance from the z-axis. Ano po tayo mass 4, which is 6 kg located at 0.35 meters from the fixed axis. And then napod tayo mass 5, 1 meter kanang kuan 10 kg. Mass 5, 10 kg, 1 meter distance from the x-axis. So since this is from the x-axis, wala man siya ikuan. So 0 yaha. 0 meaning it does not have any moment of inertia with respect to the z-axis. So we can just neglect this one right away. So again, kung wala siya distance from the given z-axis, meaning wala po siya moment of inertia at that axis. So we neglect mass 5. So proceed sa mass 6. Mass 6 is, let's say, locate siya dire. This is mass 6. Then 1 meter distance po na siya. This is 1 meter. Okay, kung ato ilista, ang given mass 1 is 10 kg. Iyahang R1 is equals to 1 meter. Mass 2 is equals to 5 kg. Ang iha distance from the fixed axis is 0.25 meter. Mass 3 is equals to 1 kg. Iyahang distance R3 is equals to 0.1 meter. Mass 4 is equals to 6 kg. Then ang iyahang distance is 0.35 meters from z-axis. Mass 5 is equals to 10 kg. Ang iyang distance kay wala man siya distance sa z-axis, sa x-axis naman, that is R5 is equals to 0 meter, meaning wala. Then mass 6 is equals to 8 kg. then R6 is equals to 1 meter from the z-axis. Okay, so required, we are going to find the mass moment of inertia along the z-axis of this given system of masses. So again, elementary definition, the formula for the mass moment of inertia for the system is just the summation of the product of mass times the square of the radius, wherein from I, starting from 1 until 6 man sila. Okay, so this one is equal to mass 1 R1 squared plus mass 2 R2 squared plus mass 3 R3 squared plus mass 4 R4 squared plus mass 5 R5 squared plus mass 6 R6 squared. So this one cancel out na nidaan tungod kay si R5 equals 0. Then plug in the values. For mass 1 we have 10 kilogram. R1 is 1 meter squared plus R2 is 5 times 0.25 squared plus mass 3 is 1 kilogram multiplied by R3.1 squared plus mass 4 is 6 kilogram multiplied by 0.35 squared, then plus 10 kilogram multiplied by 0 squared plus 8 kilogram multiplied by 1 squared. So simplifying, we have 10 times 1 is 10 plus 5 times 0.25 squared plus 0.1 squared plus 6 times 0.35 squared plus 10 times 0 mas 0 na siya, so plus 8. So the answer is 19.06, or to be exact, that is 19.0575 kilogram meter squared. Mano siya ang kanang unit sa atong mass moment of inertia, that is in kilogram meter squared. So therefore mano siya ang we have value. Okay, any question? Okay ra? Okay, so let's proceed to the next. Or for this case, last problem. So here, let's write first the figure and data. So diri, ingon siya, calculate the mass moment of inertia of a circular ring with outside radius of 5 cm and inside radius of 2 cm, thickness of 0.5 cm and a density of 2000 kg per cubic meter. So we have here a circular ring, the drawing, then of thickness, of known thickness. Okay, then rotating or nasa axis dire, we just call this one as the x-axis. So we have R1 and then of course R2 and then we have thickness. So we all know that R1 is the inside radius, that is 2 cm. R2 is equals to 5 cm, which is the outer radius. The thickness is 0.5 cm, and then we are given density is equals to 2000 kg per cubic meter. Okay, ang required here, so required is we're going to find the mass moment of inertia, I at the x-axis. Okay, so solution. So from our previous derivation, we all know that the mass moment of inertia for a ring is equals to its mass divided by 2, then the sum of the squares of the inner radius and the outer radius. Okay, so we have inner radius, we have outer radius, but we don't have mass. But we know that we have a formula that density is equals to mass over volume. and that we know that mass is equals to density times volume. Okay, we have density but we don't have volume, so we can just solve for the volume. That is, the volume for a ring is just 2 pi r squared. So since doon siya ka r, so i-subtract ra. So 2 pi t, then r2 squared minus r1 squared. Okay, the density here is 2000 kilograms, so right here 2000 kilogram per cubic meter, then multiplied by 2 pi. The thickness is 0.5 cm. Since ang density ka in cubic meter, so i-convert ni siya into meters. That is 0.5 over 100, so mahimo na siya og kanang kuan meters. Then the outer radius is 5 cm, that is 5 over 100 then squared minus 2 all over 100 squared. So ato na siya gi-convert para ma-uniform ang ato ang kuan, ma-uniform ang atong units. So simplifying this, we have 2000 times 2 pi, then multiplied by 0.5 over 100, then multiplied by 5 over 100 squared minus 2 all over 100 squared. Then ang atong answer is 0.13195 approximately. The mass is approximately 0.13195 kilogram. Kaya cubic meter man diri. Makansel na siya. So that is the mass of our disk. Since we already have the mass, so therefore we can just substitute it directly to our formula for our mass moment of inertia. So mass is 0.13195 kilogram all over 2. Then our radius is in centimeters. So para naatay mass moment of inertia nga kilogram meter squared, so ato na siya i-convert. So R1 or the inner radius is 2 all over 100 squared plus the outer radius is 5 over 100 squared. Okay, then simplifying, so we have 0.13195 divided by 2 multiplied by 2 over 100 squared plus 5 over 100 squared. So the answer is very small kayo, that is 0.1231933 kilogram meter squared. So this is our answer. Pangutana. May pangutana? Mr. Pagas? Okay ra? Okay. So, ito kita ng oras. 9:28. So, let's proceed na to the next nga discussion. So, we're going to talk now about stress. So basically for a material, so for solids, stress is defined as the force per unit area. Okay, if we're going to talk about fluids, this is pressure. Diba, ang formula sa pressure is still force over area. So for solids, we call this one as stress. So the higher the value of your kanang force, of course mas stress pod ang material. Now kung ang force pod nimo gi-apply pod sa very small nga area, then dako po kay kaog stress. So dako kag stress. Now in symbol, we can write this one as kanisiya, kaning small letter sigma is equals to the force all over the area. Okay, when this kanang formula class for stress, we can have several types since ang force has several types. So I hope inyo pa rin na-remember itong discussion for the types of forces. So Mr. Pagas, can you give me one example or one type of kanang force na imong nainumduman so far? Unsa man to siya, Mr. Pagas? Unsa man imong nahinumduman so far nga mga types of forces? What else? Mora? Okay, tension force. So, kanang tension force gamit na ari. So, since we have several types of forces, then we also have several types of stress. So, let's start by having the first type. So, the first type is we have tensile stress. Okay, so tensile stress, this is a stress due to tension or ato siya gi-pull. Now, kung ato i-pull ang material, of course, maka-experience na siya og stress. So, let's say we have here a rod. So, natay simple nga rod. And then, the rod, of course, has a cross-sectional area denoted as AC. So, again, this is our cross-sectional area. And then, di ba, ang tensile stress is associated with tensile force. So, we have here tensile force. Tensile force. So, here, at siya gi-pull. So, we have here Ft. So, that is for tensile force. At siya gi-pull pod, Ft. So, may binat siya. So, may stretch siya. So, may stretch niya. And then, ang kanipong for tensile stress, ang ato force kay applied or Ft, at ibutang ha, this is for tensile stress. Our Ft is applied. Ang saman kanang kwan, Mr. Pagas, is it kanang parallel to the cross-sectional area AC or perpendicular to the cross-sectional AC? Based on our figure here, asa man ang directions of force, is it applied parallel to the cross-sectional area kaya ang gishadan or perpendicular? Parallel kani siya, di ba? Nag-ana man ko to i-zoom mo. Okay, perpendicular, dili siya parallel, perpendicular ni siya. So, therefore, we can say for a tensile stress, the tensile force is applied perpendicular to the cross-sectional area AC. So, muna siya. Kung makasugat mo tensile stress, ang Ft gyud kay applied na siya perpendicular to the cross-sectional area. So, therefore, we can say that the tensile stress, actually, that is abbreviated as a small sigma, then T is equals to the tensile force Ft all over the cross-sectional AC. Now, for a rod or for a cylindrical rod, of course, kay bao naman ta sa cross-sectional area sa cylindrical rod, which is a circle. So, therefore, we can say that for a cylindrical rod, it is Ft all over pi over 4 the diameter of the cylindrical rod squared. That is the tensile force for a rod. For other objects po, so mag-vary po nato ang cross-sectional area. Okay. Palay question regarding ani. So again, tensile stress is a tensile force due to the tension or pull. Then ang application sa force is perpendicular to the cross-sectional area. So this is the first type of stress. The second one is, we call it as the compressive stress. So ikaduha, we have compressive stress. So for a compressive stress, this is a stress due to compression, or imo siya gi-push, imo siya gipagamay, imo siya giduot. And then for a compressive stress, this is associated with, of course, compressive force or pushing force, compressive force. And then let's say we have a rod, not a rod, and then the rod is on the ground or on this surface, and then we apply here FC. So FC is denoted for the compressive force, FC, and of course this one ang gisidan mo na siya ato ang cross-sectional area. So for a compressive force, again the same with tensile force, kay tungod kay imo siya gi-compress, so kana siya nga rod over time mugamay ni siya, so mahimo na siya mayanin ni siya kay imo siyang gi-compress, so gamay siya, unlike with tensile nga mo inat. So for compressive, again the compressive force is perpendicular to the cross-sectional area. So in symbol, we can say sigma, small to sigma c is equals to the compressive force all over the cross-sectional area. Now for the cylindrical rod, the formula is FC all over the cross-sectional area of the cylindrical rod is just a circle, that is 5/4 d sa rod squared. So this would be the formula for the compressive stress for cylindrical rod. In other geometries, of course, mag-vary gihapon na siya. So again, duha na ta ka buok types, tensile at compressive. So both of them has the same direction for its applied force, which is perpendicular gina siya sa cross-sectional area. Okay, walay pangutanaan ni. How about you, Mr. Pagas? Na question regarding so far sa two ka mga types of stresses? Wala na. Okay, naatay katulo and probably the last. Ikatulo kay gitawag nga shear stress. So ang shear stress gigisi ang ato ang material by the word itself, shear. So we have shear stress. Shear stress is due to the shearing force, ang paggisi ni siya. And then for shear stress, unlike both tensile and compressive force, lahi ang application sa ang force. So let's say we have here a figure. So nata di figure nga duha ka metal. So natay duha ka metal ani. Then of course natay bolt. Then of course naputay nut ari. Okay, assuming nga bolt ni siya. Okay. So ang shearing stress may tabo kung apply ta ni og let's say force here. This is the shearing force. Of course ito binaton na ri Fs. Of course over time what happens diri Mr. Pagan say may tabo kung birahan ni mo diri ang say may tabo sa atong bolt. Say may tabo sa atong bolt, Mr. Pagas. What happens? Ha? Di, hugot naman siya daan. Gisecure naman na siya. And then, imo siya birahon ni kaning block. Kani siya. Imo ato ning birahon. birahon po ni sa pika side, birahon po ni sa other side. Unsay may tabo sa 2 bolt. Mabawg or in short kung dako kayo magisi. Sakto ba? Di ba? Maputol. Okay. Asa man siya dapat ma-shear. So, ang shear mo to siya magisi or maputol. Di ba? Maputol siya ani nga area kani. Di ba? Okay. Mo na ang gitawag nga shear area. We are going to abbreviate that one as the AS. So, kung ato na siya i-top view, ang forma sa bolt, di ba, kay circular. AS. But, ang atong force, kung nakatop view siya, ang atong force kay paana na. Natay FS shearing on the other side and also on the other side FS. Both have the same magnitude. Okay. So, from our figure, Mr. Pagas, what is the direction of our shearing force? With respect to our area, okay, shear area. So therefore, this time, unlike the two types of stress, the shearing force now is parallel. So sakto ka, parallel to our shear area, parallel to AS. So in symbol, di na ta magamit og katong small sigma. For shear stress, palahiin mo gani siya ang gigamit sa bukay kaning tau. So tau is equals to the shearing force all over the cross-sectional area AS. This time, still round man siya. So 4 bolts, that is just equal to the shearing force. Kani siya shearing force Fs all over pi over 4 d squared. So 4 bolts with outside diameter na siya, outside diameter of d. So mana siya ang formula. Tau sa bolt is equals to Fs all over pi over 4 d squared. But it also depends upon the system or the diagram. And then kung naatay formulas for shear stress, nabot tayo lain nga formula po ani aside from this. Kaya itong kuan man siya, dagan mo gay orientation for shear stress. We also have, let's say, this one. We have here a fixed ground, and then we have here an object, a rectangular object. And then what if ma-apply tag force sa upper part? So if ma-apply tag up force nga F, shearing force sa upper part, di ba what happens to this block, assuming nga naka-fix siya kani nakapilit gini iyang lower side. So what happens is that mubawg ni siya, di ba, maana ni siya, assuming nga dili compressible lang ato ang object. So maana na siya, ma-deform siya, di ba? Deformed siya by a certain angle theta. Okay, so by definition of our shear stress, so we all know that shear stress is equals to the shear force all over area, right? Shear force all over area. Okay, so unsa may area na to ani? Ang area na to ani is kani siya, kani iya na move tungod kay, di ba, himbaw ba ani ang block. So kani siya, this area here. Okay, so kana siyang area. And then tungod kay naka-angle man siya, naka-angle theta man siya. So unsay value ana nga kanang area kay naka-angle man siya. So the value for that is equal to Fs equal, tau is equals to area sine of theta na siya. But since tungod kay compressive ni siya, gi-assume na lang class, especially sa book, kaning sine theta is just equal to the theta itself in radians. Kay gamay naman kaning movement ni ani. Kay diba the area should be parallel to the direction of force. So therefore we can say that for this type of shearing, kaning na kay object niya display siya at a certain angle. So we have here Fs all over area times the angle of deformation. So this one is the angle of deformation. Okay, this one is in radians. Dapat is in kung ano siya naka-radians din siya. Okay, mura na ang tigamaan. Now for the first formula, kay nagkano siya. Nag-base siya sa elementary definition for shear stress. That is the applied shearing force all over the shear area, which is parallel to the direction of our force. So, naipangutan na? Question? Wala na? Okay. Let's go to the fourth principle of our stress. Ikapat nga kanang principle nga ito pwede remember is ang gitawag nga Young's modulus. Young's modulus. Or what this is also known as the modulus of elasticity. So nga nagitawag man siya modulus of elasticity. Actually na discovered ni siya ba ni Robert Hooke kay ang Young's modulus ang iya formula ani is migamit siya aning Hooke's law. So napada ni Hooke's law. Wherein gi-state sa Hooke's law that the Young's modulus Ym is the ratio of stress over the strain. Okay, mao siyang Hooke's law. But since we don't have any strain pa, so di pa nakuha sa Young's modulus. Now, start as a strain. So, for 4.A, mag-discuss po ta og strain. Actually, the strain is just the percent change of the dimension of the object. The dimension of the object. Along the applied force. Along the applied force. Or we call that one as the linear strain. So for strain class, let's say we have here a rod. Okay, kung ato siya gi-pull, diba, we have an initial length. Let's say that one is LO. Okay. Since gi-pull man siya nato with a tensile, diba, tensile man kung mag-pull ta. So, ang second result niya kay mo increase siya, diba? Sin mo na yung original ay kaduha kay, let's say that is L. Okay. Sorry. So, erase. So, midako siya. Mi-increase siya to a second length nga L na siya. So, mo ni midako na siya tungod kay gipul nato, midako iya length. Now ang strain, so magyapon ni FT, this one is FT. Okay, this is the first condition or first situation, the second situation. So the strain, actually this is abbreviated by E, is just equal to the change in length or change in dimensions. So change in length, again na dapat ang dimension nato should be along the applied force. Since ang applied force kay along ani, so length ang atong gi-consider. Change in length over the original length. Change in length over the original length. Mo nang gitawag siya og percent change. So, unsa may change in length nato, we can just denote that one as delta L. Delta L all over the original length is LO. So what is delta L? Delta L is just the final L minus LO all over LO. Now, if the strain is positive, ano sa indication ani Mr. Pagas? If we arrive a positive value for our strain E, ano sa pasabot ana? Is it tension or compression? Kay tension, tungod kay mitaas siya. So, kung positive ang value sa atong strain, this is tension. Tapos na erase ha. So, if we have a positive value, this is tension. If we have a negative value, of course, the opposite, compression. Meaning, ato siya gi-compress. Or gi-push. Okay. That is the formula for strain. So again, that strain is the changing length over the original length. Okay, so since we already have the principle for strain, then we are ready to derive the formula for our Young's modulus using the principle of Hooke's law. So by Hooke's law, we say that the Young modulus, actually ang Young's modulus di ay kay gi-abbreviate na siya as E. So, or modulus of elasticity E. Now, the modulus of elasticity is dependent upon the property of the material. So, by Hooke's law, E daw is the ratio of the stress, that is sigma, small sigma, all over the strain, that is E. Okay. So sigma all over strain kanisiya. And then let's say if we have a figure here, simple figure lang ha. Let's say we have here an applied force. So ato lang i-general, that is FC, and then of course natay cross-sectional nga AC. Okay. Here we know that from the figure, the definition of stress is the force F all over the area, right? FAC, and then the strain E. And then we all know that the formula for strain, diba? We all know that E is equal to the change in length. Let's say this is L, the length. So we know that strain is change in length over the length or the original dimension. So plug in the values, that is FAC, then this is delta L all over L, so mabuta na siya sa babaw. So therefore our modulus of elasticity is just equal to the force times the length over the cross-sectional area multiplied by the change in the length of our material. Or in short, you can have a mnemonics here. E is equals to FL over AL, FL over A delta L. Now, kung atong gipangita pod, here we can derive. How about if we're going to find the deformation? So diba, since delta L here is the deformation or elongation, okay, slash elongation, so therefore makaderive itag formula sa elongation. So we just interchange E and delta L, that is delta L is equal to FL over E or AE. So this is the formula for the deformation or elongation of a certain object, subject to either tensile or compressive. Now again, kung ang deformation diri kay positive, that is in tension. If it is negative, then that is in that is in compression. Now, ang shear stress kay dili siya ma-apply aning Young's modulus. Actually na siya lain nga kanang na siya kanang lain nga formula gamit siya og modulus of rigidity. Anyways, kani siya mga topics ma-discuss pa ninyo sa strength of material. So by kanang ato diri is ang simple lang niya nga mga principles nga ato magamit. So again, the modulus of elasticity can be derived by using the principle of Hooke's law. Okay, nakuha ra? So that is the Young's modulus. The last principle, the fifth principle, is we call this one as the Poisson's ratio. Poisson. So atong sulat ha. For stress ni siya under the principle of stress gihapon siya. So Poisson's ratio ana yung spelling. Poisson's ratio. This one is just the ratio of the lateral stress over lateral stress over longitudinal stress. So longitudinal stress. Okay, unsay pasabot aning duha ka mga answer word, because from our kanang discussion ganiha duha ra man to, tulo ra man to, shear, tensile, compressive, di ba? Unsa man yung mga lateral stress o longitudinal stress, class? So let's start with lateral stress. Lateral stress mo ni siya ang stress perpendicular to the longitudinal stress or the normal stress. Okay, ug ang kaniya atong gitawag class nga normal stress mo to siyang stress due to tension, compression, mo ta siya. So let's say, para atong visualize, let's say if we have a rod, try exage niya. Exage na to pag drawing. So if we have a rod here, dako kay nga rod, and then if ato na siya gibunlot ari, so na siya cross sectional area AC. As siya gibunlot ari, i-apply na to og tensile force. Okay, unsa epekto ani? Ikaw, Mr. Pagas, sa tinuod nga kuan, mukan ba siya like kanang muinat lang ba siya, and then ang iyang cross sectional area before and after pareho lang ba, like ang length ra ba may mausab or napailaan niya mausab? Mahimo siyang L2. Okay, in reality, Mr. Pagas, ang length lang ba ang ma-deform or naapay laing dimension nga ma-deform? Unsa man? What do you think? Sa actual gid nga object, mo change ang iyang unsa man? Kana sakto. So kani siya mo compress po ni siya tungod kay gibinat nimo, kani mo compress po ni siya. So therefore mo change na yang cross sectional area. So from the initial cross sectional area until another value for its cross sectional area. So kanang pang change nato ni ini mo na siya gatuwag nato nga kuan lateral stress. So natay stress manggod padong sa radial direction inward. So napatay force ari. So kung pilay magnitude sa force ari, napa siya percentage nga equivalent padoong sa radial direction, and that percentage corresponds to the value of our Poisson's ratio. Mo gay natay Poisson's ratio kay iya i-determine kung unsa ka sturdy ang ato ang material. Now kung dako kag kanang Poisson's ratio, ikaw Mr. Pagas, unsay indication ana kung dako tag value sa atong Poisson's ratio, because Poisson's ratio I think marag E man siguro na is equals to the lateral stress all over the longitudinal stress. Now kung dako tag lateral stress, tungod kay ingon ko nga ni kuan siya, dako siya kuan lateral stress, or dako day siya kuan Poisson's ratio. Kung dako siya Poisson's ratio, di ba, dako siya lateral stress, meaning ang atong object kay dali ra siya mogamay, di ba, tungod kay ma-compress man siya pa inward. So let's say naatay nga ning rod, and then kung dako siya, if E is higher, dako siya Poisson's ratio, therefore mo na ni siya noon mogamay pud kay niya, mutaas pud kay siya, or in other words elastic. Okay, elastic kay siya. Now if you have smaller value of Poisson's ratio, so ang imong kuan ana kay mo na gyapon siya ma-retain iyang cross sectional area, then mo elongate lang siya, dili maapektuhan iyang cross sectional area kung gamay ka og Poisson's ratio. So now we already done with the lateral stress, so ato ikuan ang longitudinal stress. Pero kaning longitudinal stress magod kay buwan naman tani, because this is just equivalent to the normal stress, which is a stress applied along the applied force. So ang longitudinal stress ani kay kaning due to Ft. So longitudinal stress is just equal to the normal stress, that is theta, I mean sigma, which is equal to the applied force over the cross-sectional area. So basically class, wala gyud anon gyud ani mostly ang lateral stress. So if we're going to solve for the lateral stress, what will you do? You just multiply the Poisson's ratio of the material, because this is dependent upon material property. So material property, this is a constant value. So therefore, kung makakuha na kag normal stress or the longitudinal stress, then you can solve directly the lateral stress by using the formula for Poisson's ratio. Again, formula for Poisson's ratio, that is E equals the lateral stress all over the normal stress or the longitudinal stress, or theta normal. Muna siya ang Poisson's ratio. Again, if you have higher value for your Poisson's ratio, therefore ang imong object kay mo deform siya or mo gamay iyang cross-sectional area. Now if you have kanang smaller value for your Poisson's ratio, meaning dili kayo mo change ang imong cross-sectional area sa imong object. Okay, nakuha ra? Mr. Pagas, do you have question? Okay, so if you don't have any question, again, marami mga basic nga mga principles nga makover sa stress, but actually sa inyong strength of material pohon, daghang po may masugatan ng mga formulas for stress. So basically, for solids, define as force over area. So hinumduman natay tulo ka types of stresses. We have compressive, tensile, and shear. Then we can relate also the shear stress and the strain by using Hooke's law, so that we can arrive the value of our modulus of elasticity, moto siya, which is the ratio of the stress over the strain. And then kana po mga atong modulus of elasticity, and also lastly this fifth topic, kaning Poisson's ratio, they are dependent on the property of the material. Okay, Marcia, and then Poisson's ratio, again, the ratio of the lateral stress over the longitudinal stress or the normal stress. So the higher Poisson's ratio you have, then the probability nga mugamay dayon ang imong cross-sectional area sa imong object. But kung less ang imong Poisson's ratio, gamay value, meaning kanang dili dayon ma-deform or di dayon mo change ang cross-sectional area sa imong object. Now, for modulus of elasticity, katong E ganiha, kung dako kag value sa imong modulus of elasticity, so dili kaayo elastic ang imuhang dili kaayo elastic ang imong object. Why? Because di ba again, modulus of elasticity E is equals to the stress over the strain. So kung dako kani siya, gamay kani mong strain. And then di ba strain is associated with deformation. So meaning dili elastic ang imuhang material, gahi kani siya. Now if you have small value for your modulus of elasticity, meaning your material possess a considerable amount of deformation, therefore that is elastic, given that our normal stress is constant. Okay, so kung walay pangutana, then let's proceed to problem number 1. Application for stress. So here we have a load of 5 kg is attached to the free end of a wire of length 2 meters and diameter of 0.6 meters. So for a certain to answer real life nga mga problems, so mas better nga ato i-draw and then indicate ang mga important nga mga givens, because that would serve as our data. So here na daw tay wire. So let's say na tay wire. So ato lang i-exage ang wire nga makita na iyang cross sectional area. Ang wire is 2 meters. Wire is 2 meters. So naka-attach na siya ang wire to a certain and then diameter of 0.6 mm. So therefore we have here a diameter D is equals to 0.6 mm. If the extension of a wire is 0.2 mm, so therefore may extend daw ni kay gi-suspend ba daw ang load. So therefore ni extend siya, exaggerate ni para maklaro mo na iya extension. Naa diri nakakabit ang load nga 5 kg. So this one is 5 kg. Okay, mo na siya ang iyahang nasukod nga 0.2 mm. 0.2 mm. Okay, kanang Mr. Pagas, unsa man ning 0.2 mm? Unsa ni siya? Okay, so sakto, this is known as the deformation or elongation. So 0.2 mm. And then calculate daw the Young's modulus of the material of the wire. So we're going to use the acceleration due to gravity G. So natay G ari because natay mass 9.8 meter per second squared. So our requirement here is we're going to solve for the modulus of elasticity E. So solution, actually kanang gibutang diri nga mga remaining, so di pang lista na ni ang mga given. Okay, so solution. Okay, since gipangita si E, of course, ato tong gamiton tong formula for E, which is the Young's modulus or the modulus of elasticity, right? Young's modulus. So E is just equal to the ratio again. Ang sa to, Mr. Pagas, ratio of the, kung nakainomdom ka, E is the ratio of, okay, stress over strain. So sigma, small sigma of all over this small nga kaning E. And then masama ning type of stress. Si wire daw kuno kay na ay may suspend niya 5 kg nga mass. Masama ni siya nga type of force. Is this compressive or tensile? Okay. So tension. So therefore, ito is what the stress in tensile is just equal to the force all over the cross sectional area divided by the strain. Again, sa strain, that is just the change in length or the deformation divided by the original length L. Okay. Here class, unsa man ang atong force? unsa may force nato, unsa may since ingon man ta nga tensile force, unsay force nga may bira sa ato ang wire? That is equal to unsa man Mr. Pagas? Unsa man ka ang may bira ani nga force? Unsa man kay force ani nga may bira? Unsa may value sa atong force ani, naka-idea? Okay, or equal to the weight. Diba weight? Mass times G. Okay, so our mass here is 5 kilogram and then our gravity is 9.8 meter per second square. So, unit analysis, ang output kay Newton. Kay kung atom ko ni FBD, so, muna siya ang tip sa wire. Of course, gibira siya sa weight sa ato ang kanang load, weight of the load. Okay, so mana ang value sa atong force. So since given naman ang tanan, ay what else? Ang wire. So ang wire kay kuan siya round. So therefore ang iyang cross sectional area is circle. So this is AC. So therefore the force here is mg. So butan to mg. All over the cross-sectional area is for circle since ang wire kay circular man ang wire. So we're going to use mg all over pi over 4 then d squared divided by the change in length, that is pila man ang delta L nato diri Mr. Pagas? Delta L here is kani, di ba? 0.2 mm din siya. Okay, mm din siya, mm. So this is our delta L, and then this 2 meter here is our length. So therefore delta L is 0.2 mm all over our length. Original length is 2 meter. So mara itong buhaton, and then we're going to plug in the values. So mass is 5 kilogram. Acceleration due to gravity is 9.8 meter per second squared. Divide by pi over 4. Then atong diameter sa atong wire is 0.6 mm. So since ang ato acceleration due to gravity is in meters, then obliged kita nga i-convert ang ato ang mm into meters. So that is 0.6 mm, and then we all know that 1000 mm is 1 meter. Then squared. Para makancel na siya, natay meter. Then divided by, so pwede po tayo mag-over na tari. Divided by 0.2 mm all over 2 meter. Since napatay meter are, so at i-convert 1000 mm 1 meter. Okay, so makancel na siya, makancel ni. The same thing with this one, makancel. So pila yung mabilin. So we have here kilogram. Ang expected po dimension diri sa ubos kay meter squared. So therefore we have kilogram meter per second squared, that is in Newton, divided by meter squared, that is Newton meter or Pascal. So therefore ang unit niya kay sa stress is a pressure, Pascal. Then simplifying this, so we have 5 times 9.81 divided by pi over 4, then 0.6 over 1000 squared divided by 0.2 divided by 2000. The answer is 1.73 times 10 to the power 12. That is 1.73 approximately na siya. Tapos makayo times 10 to the power 12 Pascal or Newton per meter squared. So this is the modulus of elasticity of our system. Nga subject siya sa load nga 5 kg. Okay. Diri dapat kay baka mo analyze the system, then don't forget to convert your dimension para ma-uniform tanan. Okay, pangutana, Mr. Pagas. Wala na. Okay. So, proceed ta sa next nga problem. Here we have a copper wire of 3 meter length and 1 mm diameter is subjected to a tension of 5 kg weight. Calculate the elongation produced in the wire if Young's modulus of elasticity of copper is 120 gigapascal. Now, kung makasugat mo ani, so before we're going to answer this problem, kung makasugat kayo mo 5 kg weight, pasabot ana is, in order to convert that one into a weight in terms of force, so ato buhaton ana is, we're going to multiply that one by acceleration due to gravity 9.81 meter per second squared para mahimo ta og newton. So in terms of newton, ang Canada equivalent sa 5 kg weight is equal to 49.05 newtons. So 49.05 newtons. Again, kaning tension diri is kaning 5 dili pa na ang newton since gingunod ang kilogram weight. So kung kilogram weight na siya, imo pa na siya multiplyan og 9.81. Nakuha ra? So nakuha ra Mr. Pagas? Nakuha ra ang idea? Okay, so kung 5 kg weight, para imo na siya ma-convert into newtons, imo na siya multiplyan og 9.81. Okay, so proceed ta. Ato isuwat ang kanang figure and data. So here we have figure and data. So ito isuwat. Yan sa diri, a copper wire subjected to a tension of 5 kg weight. So ito lang i-exage nga si copper wire kay cylindrical since naman siya ay diameter. So si copper wire nga iyang length, original length is 1 mm, and then it has a diameter of D equals, okay, nabali di ay, ang length na to is 3 meters na siya. The original length is 3 meters. Its D diameter is 1 mm. Then subject to a tension of 5 kg weight. So gibirada ni siya. Ft is equals to 5 kg weight. So ato pa na siya i-multiply og 9.81 para mahimo na og newton. Okay. Calculate the elongation produced in the wire if the Young's modulus of elasticity of copper is 120 gigapascal. So EDI for copper Cu is equals to 120 gigapascal. In terms of pascal, we are going to multiply it by 10 to the power of 9 pascal. Sakto ba, Mr. Pagas? Ang gigapascal kay to the 9. Okay. So ato pud isuwat ang requirements. So the required for this problem is we are going to solve for the elongation. So unsa tong elongation? That is related to strain, which is denoted by delta L. So mana siya, elongation. Elongation na siya. Okay, elongation. So solution. So our system here undergoes tensile stress, diba? Tensile stress man siya, kay gipull man siya. So tensile stress. So for tensile stress, in order to solve for the elongation, we need to find a formula that will relate our modulus of elasticity the tensile stress and the elongation. So we all know that from Hooke's law, we have modulus of elasticity E is just equal to the ratio of the stress over the strain E. Or in other words, in terms of the applied force and the elongation, we have the tensile force all over the cross-sectional area AC, all over the change in length over the L. Okay? And then if we're going to eliminate fractions on the numerator and the denominator, then we simplify this further. We have F of TL all over delta L and then AC. Since delta L may gipangita, so we cross multiply, and further we can arrive this delta L equals to FT L all over cross-sectional area times the modulus of elasticity. Okay, so since this is a circular man siya nga wire, so that is FT L all over pi over 4 d squared E. Then since okay na ta, kay delta L may gipangita, the elongation, so we just plug in the values. So for our force, that is 5 kg weight. Then ato pa na siya i-multiply yung og 9.81 para man-newton siya. So that is 5 times 9.81. The result is newton. Then the length here is 3 meters. So that is 3 meters divided by pi over 4. Then the diameter here is 1 mm. So since atong length is in meters, so dapat consistent ta og units. So ang kaning 1 mm ato i-convert into meters. So 1 mm divided by 1000 mm is 1 meter squared. Then the modulus of elasticity is in Pascal. So that is pila to value, that is 120. So 120 times 10 to the power of 9 ang iyahang unit kay Pascal, or this one is Pascal or Newton per meter squared. So may butang, that is Newton per meter squared. So makancel ang Newton sa babaw, then kaning meter ari kay makancel na siya because the result here is meter squared. So makancel meter to ang final answer nato sa elongation is in meters. So delta L is equals to, simplifying, that is 5 times 9.81 times 3 divided by pi over 4, then 1 over 1000 squared, then kana siya is 120 times 10 raised to the power of 9. So ang result niya kay approximately 0.00156 meters, or in terms of millimeter na lang. So ato na siya multiplyan og 1000 para mahimong mm. So ang answer kay 1.56 mm. That is 1.56 mm. Mo na siya ang elongation sa ato ang copper wire. Okay, nakuha ra? Na question, Mr. Pagas? Okay, so mo na buhaton. Now let's move on problem number 3. Okay, lingon dere what is the force required to a steel wire to double its length when its area of cross-section is 1 square centimeter and Young's modulus is 200 gigapascal? As the length of the wire is doubled, the change in length is equal to its original length. Okay, so ato sa ikuan ang figure and data. Okay, so steel wire daw. So steel wire, let's say natay steel wire ari, so extra kani. So steel wire, of course naagid tay length. And then we also have here kaning shaded region, of course, our cross-sectional area AC. Then ang Young's modulus, so that is E equals to 200 gigapascal. So ang ipangita required is the force. Maybe this one is tension or compression. So ingon da ko na siya dire kay na siya mga conditions. So money kuan ini sa pag-solve or sa pag-solve nato kay ato i-consider ang mga conditions nga naaani nga present sa atong problem. So ingon siya kay what force required to a steel wire to double its length when its area is 1 square meter. So force daw kuno kung atong length kay mo double. So let's say we have a second condition. Let's say the second condition is L2 na lang. So L2 is equals to 2L, wherein L is the original. This is the original length. Since naman condition, so ang second nga length kay mi-double sa iyang previous nga length. So na po diri sa last part, i-indicate po diri nga as the length of the wire is doubled, the change in length is equal to its original length. Okay? Natay kaduhang condition. So within this condition daw class, kung mag-change data from the second condition class, mingon siya nga kung mo double ang atong length class, ang ato pod change sa length niini katong deformation, that is delta L, is equal to the original area L. So meaning this is delta L2 kaya sa second condition naman ta. For delta L1, we don't know. So natay condition for kuan delta L2. Again, ang change in length na niya in the second condition is equal to the original length, which is equal to L. And here we are going to find the force. Solution. Okay. In order to relate the force, the deformation, and the modulus of elasticity, so we're going to use the Hooke's law. Hooke's law defined as E is equals to the stress over the strain, wherein our stress in terms of applied force, force over the cross-sectional area, all over the elongation is delta L, all over L. Rearranging, we have force times L over delta L AC. And we all know class, given man sa AC equals to 1 square centimeter. Okay, given sa AC. Now, wa man tay country no, wa man tay force ari. Wala po tay L. Okay, wa man tay L diri. So this is from kanang kuan. This is from the first condition. So wa po tay delta L2. So kani siya first condition ni siya. First condition. How about for the second condition? So yung mandiri kay mi double ang length. So that is the same ra gyapon ha. For the second condition, same ra gyapon ang modulus of elasticity E, since nagdepende man na siya sa material. Wa man nato giusab ang material, so remain gyapon siya as E. And this time our force now is mo na siya ang force nga atong gipangita. Force then times the length. What is now the length for second condition? That is L2, which is equal to twice the initial length. So 2L divided by the change in length. What is the change in length for second condition? That is equal to L multiplied by the cross-sectional area. So here wala po nag-vary ang atong cross-sectional area. That is just equal to 1 centimeter squared. So that is 1 cm squared. Here sa numerator o sa denominator, we have L, so makancel na siya. So therefore we have E is equal to 2F all over 1 cm squared. Now solving for F is equals to 1 cm squared multiplied by E divided by 2. Okay? So, ato na i-substitute ang mga values. So, para uniform ta og the dimensions, ang centimeter ato na siya i-convert into meter. That is 100 cm is equals to 1 meter. Since naka-square man siya, so square po rin nato siya. Then, ang E nato is 200 gigapascal, or that is 200 times 10 to the power of 9 Newton per meter squared divided by 2. Here, this is in meter squared. Kaning 1 cm squared pag after to convert into meter. So, makansel na siya. Now, sakto atong assumption kaya ang force is in newtons. Simplifying this, we have 1 over 100 squared. 100 squared, then multiplied by 200 times 1000, 10 to the power of 9 divided by 2. So, ang answer ani kay 1. Dako ni. Sa 2, 3, 4, 5, 6, 7. So, that is 4, 5, 6, 7. So, that is 10 million newtons. Or, pila man yung 10 million kanang newtons. Same rin pa na siya sa 10 mega newton. So, mega newton. So, muna siya ang force nga ito yung apply. Nakuha na na? May question so far? Kaya nakuha na? So, dako kaya ang force kay i-double mo na to ang length. Okay, if wala question, then let's proceed to the last problem for stress. So, kanisiya, ang problem 4, kanisiya kang situation. Imo i-judge kung asa may stronger. So, here, it's stated here that which is stronger in terms of tensile strength, meaning we base our criteria on the tensile stress of the material. So here, it's stated that which is stronger, a solid rod daw with outside diameter D and a length of L, or a hollow rod ba daw with outside diameter D, inside diameter D, and a length L. So both are of the same material. So write figure and data. Figure and data. So naatay duha nga gi-judge. First one is the solid rod. Okay, kung rod gali ang shape kay cylinder, and the next one is a hollow rod. Both of them are subject to a tensile stress. So for solid rod, mo na siya. Na siya L. Then solid man siya, so solid yung cross-sectional area, na siya outside diameter nga D. Subject to a tensile force F. Tensile force F. Okay, assuming pag test nato is the same ra ilahang tensile force nga gigamit. I mean, ang direction sa tensile force kay pababa, pataas. Okay, tensile force, then ano siya. For hollow rod, ano ni ang hollow rod class? Nasa buho. Okay, nasa siya buho. So, mana area cross-sectional area kay morning shaded man. Nasa buho, meaning it has diameter on the outside, and then it also has a inside diameter abbreviated as small letter D. Then same ra silang duha og length yun. And then of course same ra sila og tensile force Ft. And then class napatay usa ka criteria. I mean usa pa day ka parameter nga present nilang duha. Unsay pasabot ani Mr. Pagas kaning both are of the same material. Sa itong storya bahin sa ilahang modulus of elasticity. Sa atong mastorya ni Mr. Pagas, if they have the same material composition, unsay value sa ilahang modulus of elasticity E? Okay, parehara. So therefore, ang E sa solid, is equals to the modulus elasticity of the hollow. Okay, then required which is stronger in terms of the tensile strength. Asad ako na yung pinakakusgan nila. So sa imong pangagpas ani kanang kuan Mr. Pagas, asa man kahay may kuan, asa man ka ang kusgan nila, ang solid rod or ang hollow rod? Imo lang intuition. Solid siguro. Okay, solid rod. Okay, let's try to find out by using the tensile strength nga criteria. So by tensile strength, mag-una ta ni solid. So di ba ang formula for tensile strength, di ba, is kanang sigma, small sigma. So this is for solid. So we indicate this one as sigma solid is equals to the applied force. So that is Ft all over the cross-sectional area for solid is pi all over 4, then d squared, di ba? And then for the hollow is sigma hollow is equals to the force all over pi over 4, then ang iha diameter is the difference, di ba? Nakuha Mr. Pagas, kaya ang iha top view ani sa iya cross sectional area is ana. So difference siya, oo, naman siya buho. So therefore we have the square of the outer diameter minus the square of the inner diameter. Then this is Ft. Here, kung imo kita ng kuan, maglisod ta og kuan sa ilaha. Dito sa tag-judge niya. But if we're going to let some value, let's say our tensile force is 2 newtons. Our outside diameter is, let's say we have exaggerate gini siya. Let's say 1 meter. Ang iya inside diameter for hollow is, let's say 0.5 meters. Or pwede po kuan para medyo di kayo katunga, 0.75 lang, pwede ra kayo 0.75. As long as nasa buho, mara gyud na ato ang hollow na gyud siya buho compared sa solid nga wa buho. So that is 0.75 meter. What else? So I think okay na. So what we need to do is ato siya is substitute para makaibata kung asay dakog value sa ilahang sigma, then siya ang ato ang winner. So that is 2 newtons divided by pi over 4, then d here is 1 meter, then squared. So the resulting answer is in Newton per meter squared or Pascal. That is 2 divided by pi over 4, then 1 squared. So we have approximately 2.55. Approximately 2.55 Pascal. That is the strength of our solid nga rod. How about for hollow? That is theta hollow is equal to 2 newtons nga tensile force divided by pi over 4. Then the diameter, the outside diameter is 1 meter squared minus the inside is 0.75 meter squared. Again, The answer is in Pascal gihapon. 2 divided by pi over 4. Then 1 squared minus 0.75 squared. The answer is 5.82. Approximately 5.82 Pascal. So, based sa atong result pagas, asa may mas kusgan? Okay, ang halo di ay. So, at first, makaingon ta nga ang solid tungod kay solid siya. However, by looking at our formula for stress is equals to force over area, di ba, Mr. Pagas? And then, okay, so di ba, nganong unsay nahitabong anong hindako ning stress sa halo? Asa nga parameter siya ni bawi? Sa iyahang, unsa man? Nganong dako makaiya stress, asa man ani nga parameter siya nakabawi compared sa solid nga rod? Diri siya sa iyahang cross-sectional area, di ba? Do you agree, Mr. Pagas? Kanay siya AC. Okay, kay sa hollow manggod, gamay iyahang cross-sectional area tungod kay hollow siya giban, and therefore dako iyaha stress. Unlike solid, solid man siya, meaning dako iyahang cross-sectional area. So therefore mo gamay pud iyahang iyahang stress. So ang answer ani, hollow rod is stronger than solid rod. Okay. Given nga the same sila og length ha, the same sila og length, the same sila og material, and then the same pud atong gi-applied nga force. Okay, walay question so far, Mr. Pagas? Okay, I think that is the end of our discussion. So for this lesson,